Welcome to this video. In here I'm going to introduce chi-square tests. So welcome to a whole unit with whole new chapter. The chi-square test is different with all of the tests we did previously. I mean, it's not completely different, take my words back, but there's definitely some nuances we have to pay attention to. So before we often talk about the test for means or proportions, in here I want you to focus on is chi-square test is only for proportions, and it only has test. There is no confidence interval for it. And didn't we already do this? So take a look at this example for a minute. Here's the data that collected for top CEOs for Forbes Fortune 500 companies. And the question that we want to investigate is, do successful people fall under one zodiac sign more than another? We could do this with multiple z-tests for two proportions. So, for example, if we want to do Aries versus, please forgive my pronunciation if I do it wrong, but Taurus, like if we want to compare these two, I would just shorthand them as A and T. So if we want to compare with A and T, that's one comparison way. If we want to compare with A and G, that's another one. So you can see if we want to compare A with all of the, all rest of the zodiac signs, there will be total 11 combinations. And same thing for T. There's 10 combinations. For G, for C, each one, as we go on, the combination total number decreased by 1. So if you want to do it by hand, you can just do 11 plus 10 plus 9 plus 8 all the way to 1. Because at the end, there is only one combination for P with itself. But that's kind of tedious. How about do it on the calculator? So how to do it on the calculator? We can use NCR, since we don't care about the orders. So we choose 2 from 12. From the calculator, we get 66 combinations. We can do this with multiple z-tests for two proportions, but it becomes too complicated and the p-values add up. So instead, we will work with what is called a chi-square test. So what is chi-square test? There's 3 different chi-square tests. First one is chi-square goodness of fit test, which is also the one that we're going to focus today. The other 2 we're going to introduce later on in other videos, but in here we're just going to introduce GOF. Looking to see if your distribution matches the claimed distribution. And one population or one sample or one variable. Those are the 2 key statements we have to pay attention to, and those are the alignments or some keywords we can help ourselves to find out, okay, this question needs a chi-square test instead of z-test or t-test. So all 3 chi-square tests note only test, and that's what I mentioned early in this video. There's no confidence interval for chi-square tests. The conditions are those following 3. First, data are counts. This means that our data is categorical variables. They are not continuous values, and that's one of the purpose that we're doing it. Before we investigated the objects or the experiments was implemented on things that can be count, or not can be count, but they just have decimals or fractions. But in here, it's all whole numbers. Or another way you can think of that is we are investigate different types of things. So you cannot really quantify an object or different objects. Therefore, we're only investigating the categorical variables. Second is simple random sample. That's the same for all 3 types of tests we did so far. Third step is expected counts are at least 5. And what I mean by that is once we got a list of values that we are observing, we will get the expected value from our calculator, or you can do it by hand, but that will be tedious. So once we get that number, we're going to check if it's at least 5, or at least 80% are greater than 5. And I'll show you later in the example how are you going to implement it. And the test statistic or the formula that we're going to use is this one. X squared equal to the summation notation, so the sum of the observed minus expected quantity squared over expected. And remind ourselves a little bit, when we're doing z-scores, we got x bar minus mu all divided by standard deviation over square root of n. This is when we're finding z for means. When we're finding z for proportions, we're going to use p hat minus p over square root of pq over n. When we're doing t test, finding t, we're going to use x bar minus mu over s over x square root of n. And so just a little reviewing in here, you can see the difference with chi-squared and the other value formulas we've been using. Also remind yourself, chi in here, it looks like an x, but it's pronounced as chi. And since it's squared, we're going to put 2 in here. So don't be surprised. Oh, oops. Excuse myself. So don't be surprised when you see x squared instead of x. So using the table, this is the screenshot of the packet provided by College Board Testing Center, which gives you the table for chi critical values. It's hard to see, but in here it's the degrees of freedom, and all of those are tail probability, p. And instead of drawing a normal curve, this will always be a skewed curve. And the probability p right here is the area that we're shading, and the value aligned with it will be our chi squared that we're trying to find. And I will dig deeper for it in later. So going back to the question, the chi-square goodness of fit. This is a type of chi-square test, and here's the example. So the first step, we also always starts with label the proportions or the p-value for what we're trying to investigate. So the probability, not probability, but like p sub a is the proportion of CEOs that are Aries, and so on. So I didn't label all of those. I didn't write out fully for 12 proportions, but just as you know, you can do a little shorthand right here. The expected value is what we're trying to find. So before we do that, let's first put our hypotheses in words. The null hypothesis will be the proportion of CEOs with each zodiac sign is the same. The alternative hypothesis is the proportion of CEOs with each zodiac sign is different across the signs. So basically what we're trying to find is to test our hypothesis is true or not. Our belief is the zodiac will impact how successful a person will be. Second step is stating that is the data counts. Well, it is, because those are 12 types. They are all categorical values. Is this a simple random sample? Well, we're not so sure, because the question didn't specifically state that those data are collected from simple random sample, so there's a question mark. The expected value, we're going to get this from our calculator. So if you're watching this video, please pull out your calculator and go into stats, edit. First, put all of those numbers into list 1. After you do that, we're going to hit stats, calc, one variable stats, and for list, you're going to put L1. For frequency list, just leave it blank, and then you're going to calculate it. That's how you get this expected value right here. So after we got that, we're going to justify if that's greater than 5 or not. And since it is, our chi-square goodness of fit test applies. In some parts of your procedure, you're going to write the degrees of freedom and alpha. I suggest you write it in step 2. The degrees of freedom will be the number of categories minus 1. How many categories do we have? We have 12. Therefore, we use 12 minus 1, which gives us 11. The alpha, we just picked a number right here, which is 0.05. Third step will be calculating the exact value for chi-square. We're going to use the formula we introduced previously, observed minus expected quantity squared over expected. How are you going to do it is that you can also go into your calculator and go into edit again. You already put list 1, and the list 2 should be your expected value. In this case, they're all the same. which means they all have 21.333 repeating. For L3, what you're going to put is L1 minus L2 quantity squared over L2, and you will get the numbers for L3. After you've done that, you're going to go to Stats, Calc, one variable stats, and hit List 3. Leave frequency list blank again, and hit Calculate. You will get a bunch of informations, and you're going to choose the second one, which is the summation notation X, which gives you 8.276. Therefore, sorry, it's not that value, but it's 5.09. Therefore, you're going to put this value down. And the p-value will be also from, the p-value will be when you hit second bars and go into number 8, which is chi-squared CDF. The lower value will be your chi-squared, and the upper value will be infinity. In this case, you're just going to type a very large number randomly for whatever you want. The degrees of freedom, remember to label it as what you found it right here. So you're going to type that value into your calculator and paste. After you've done that, you are going to get your p-value. So after we get those two values, we're going to draw a rough sketch for how a chi-squared graph looks like. So starting with degrees, the highest peak of this curve will be degrees of freedom minus 1, which will be 10, because degrees of freedom is 11. Then we're going to label our chi-squared, which is 5.09, and we're going to shade the region all to the right. And you can see that the p-value is pretty high, which corresponds to the answer we found. Last but not least, we're going to write our conclusion. We're going to start by saying at alpha equal to 0.05, which is the number that we picked, p is equal to 0.9267, which is greater than alpha. So I failed to reject null hypothesis, meaning the CEOs are equally distributed across the zodiac signs, but we're not sure if we have a simple random sample. Remember that in step 2, when we are trying to justify this is a simple random sample, we don't have enough information for it. Therefore, we're gonna draw that back again in our conclusion part and saying that we don't have enough information or we don't have enough evidence to prove our test results since we're not sure if this is a simple random sample. But other than that, everything is that. Let me just readjust the screen here. So yeah, if you follow all of those steps, you should get the same answer. And just one more thing to mention, all of those things I said related to the calculator, if you're using a TI-84, definitely will be the same, but if you're using another type of calculator, I'm not sure how your calculator has been built in for those functions. So please make sure to double check with how are you going to do it. Thank you. And for the rest of them, we will just wait for another class. So thank you so much for watching. Hope you have a great day.